Usually, though, we won't encounter rational expressions with the numerator and denominator in factored form. It's much more common to encounter rational expressions that look like this: x cubed minus 3x squared plus 2x over x to the fourth minus 5x squared plus 4. What should we do when we encounter something like this? Our first step should be to factor the numerator and denominator. So the numerator, x cubed minus 3x squared plus 2x. I see these have a common factor, which I'll factor out. And now I want to factor this remaining trinomial, splitting up the middle term as two numbers whose sum is -3 and whose product is 1 times +2. I think that -1 and -2 will do that for me. So the greatest common factor in this row is an x. In this row is a 2. X times x is x squared. X times -2 is -2x. X times -1 is -1x. -1 times -2 is +2. So we're left with x times x minus 1 times x minus 2 for the factored form of our numerator. For our denominator, well, let's see. I'm thinking I want to treat x squared as a block here. And I might write this out this way, or I might just think of it this way. Either way, I want to split up that middle term using two numbers whose sum is -5 and whose product is 1 times +4. Writing everything still in terms of x, I'll get x to the fourth minus x squared minus 4x squared plus 4. Greatest common factor in this row will be x squared. In this row, I think I'll have a -4. Here I'll need an x squared. That works. Here I'll need a -1. That works. So my polynomial factors as x squared minus 4 times x squared minus 1. Noting that each of these binomials is a difference of squares. That's x minus 2, x plus 2, x minus 1, x plus 1. All right, so I've factored the numerator and denominator completely separate from one another. Just as I did, if you'll recall, when I was working with numbers. So now I rewrite my rational expression in factored form. My original rational expression was x cubed minus 3x squared plus 2 over x to the fourth minus 5x squared plus 4. Excuse me, I had a 2x in the numerator. In factored form, that will be x times x minus 1 times x minus 2 over x minus 2 times x plus 2 times x minus 1 times x plus 1. And now I cancel any common factors. I see x minus 2 as a factor in both the numerator and denominator, x minus 1 as a factor in both the numerator and denominator. What am I left with? X over x plus 2 times x plus 1. The good news is, usually I will leave this in factored form, because usually factored form will be more convenient for whatever it is I plan to do next. If I have a compelling reason to want it multiplied out, I could multiply it out But unless I need to, I'm going to leave it in factored form. Now I'm going to give you one of these to try. Simplify the rational expression 2x minus 4 over x squared minus 4. Pause the video and try this now. Alright, I want to factor the numerator fully. I see that these two have a common factor of just 2, and that's about the best I can do. I want to factor the denominator fully. Oh, I notice that this is a difference of squares, and so I can factor it as x minus 2 times x plus 2. Thus, I can rewrite my original rational expression as 2 times x minus 2 over x minus 2 times x plus 2. Those two factors are the same, so we can cancel them out, and we're left with just 2 over x plus 2. Now you might be wondering, can we still cancel out a 2 or something? And the answer to that is no. 2 is not a factor of the denominator, right? 2 in particular is not a factor of x.